Okay, this is more help on 8.6. I'm going to look at a few other problems from earlier on. So let's look at 6 again. Alright, so 6 says that you're given the equation x cubed minus 2x plus 4 equals 0, and you're given the solutions -2 and 1 minus I. And it says all but one of the equations of which are given, find the remaining root, then check your answer by substituting it in for the x in the equation. Well, so we got to find the other root. We have a imaginary root or a complex root, so the other root is 1 plus I. You can sub it in, or you can use synthetic division. Either way, I'll use synthetic division. Okay, and synthetic division is not great here because of the I, but it will work, and you get 1 minus I times 1 minus I. We get, I'm going to have to come out here and work this out, squared. So you get 1 minus 2I plus I squared, so you get -2I. -2 minus 2I. And so I get 1 minus I times -2 minus 2I. And so I get 2 is first, outside is -2I, inside is positive 2I, last is positive 2I squared, and positive 2I squared, and that's a -2 to start with, is -2, so that's equal to -4, and so 0, and so it works, and it checks. That's 8.6, number 6, it checks on it. Okay, we can try it on another one too. Okay, so this is 8.6, number 8, and that's x to the 4th minus 3x cubed plus 4x squared minus 6x plus 4 equals 0, and it gives us the roots 1, 2, and I root 2. Okay, I'm supposed to have 4 because the degree is 4, so that means I need one more, and the last one is x is equal to -I root 2. Okay, it's -I root 2 because your complex number is I root 2, so the conjugate of that is -I root 2. I'm going to do this one a little bit differently. I'm actually going to plug it in instead of use synthetic substitution, and that's because it's not a sum of a complex piece, and so I think it'll be a little bit easier here. This should equal 0, so remember we're trying to see if that equals 0. Okay, so the first part, we get I to the 4th times square root of 2 to the 4th minus 3 times -I cubed times square root of 2 cubed plus 4 I square root of 2 squared minus 6I root 2 plus 4. I to the 4th is 1. That right there is 1. And then that right there is 2 squared, so 2 squared is 4. Okay, -I cubed. Okay, I squared is -1, so -I cubed is negative I, so positive I. Okay, so that's just minus 3, and then that is times 2 root 2. I squared, or plus, no, I forgot the squared there. Plus I squared 4, so it's plus -4 times 2, that should be minus 8, minus 6I root 2 plus 4. Nice to know that is the opposite of that, so those cancel. And then Negative 8 is 4 and 4, so those cancel, so it does equal 0, and it checks out. So that's 8.6, number 8. Okay, this is 8.6, number 11. Okay, so that's x to the fourth minus 6x cubed plus 60x minus 100 equals 0. And tell us 3 plus I is a root. Okay, it wants us to solve this given the root. If that's a root, then its conjugate, 3 minus I, is a root. And so we can just go through and we can synthetic divide. Note there is a skip term. 1x to the fourth, negative 6x cubed, 0, 60, minus 100. So I'm going to go through and do this. 1, 3 minus I, negative 3 minus I. 3 minus I, 3 minus I times negative 3 minus I. You can trust me, that's supposed to be negative 10. And so I get negative 10 there. And then 3 minus I times negative 10 is negative 30 plus 10I. Okay, that's negative 30 plus 10I. And then add 60, that gives me 30 plus 10I. And then so I'm going to come out here and do this over here. 3 minus I times 30 plus 10I. Okay, so that's 90 minus 30I plus 30I cancels, minus 10I squared. That's 100. So I'll get 100, and I get 0 like I'm supposed to. Okay, I'm not really too concerned about what's left, but I do need to take this stuff and synthetic divide the 3 plus I out. So let's do that. Alright, so I'm doing 3 plus I. So 1, 3 plus I, it gives me a 0, 0, negative 10, negative 30, minus 10I. So that's 0. So this right here tells me x squared minus 10 is equal to 0. So x squared is equal to 10. So x is equal to positive negative square root of 10. So I've got solution here. Got solution here. Those two. So 4 total solutions. Now do one more of these. Okay, this is still 8.6. This is, let's do number 12. Okay, so it says x to the fourth minus 5x squared minus 10x minus 6 equals 0. It's not factorable. That's the first thing you check. It does tell me that I have a root of negative 1 plus I. Wants me to solve. Lucky for me, if they give me a complex root, I know I also have a conjugate. Negative 1 minus I is a complex root. So I'm going to do this one a different way, just to show you a different way. I know this is a root. I know this is a root. So I know x plus 1 minus I is equal to 0. X plus 1 plus I is equal to 0. So the product of those, okay, is a root also. So that's x plus 1 squared minus I squared is equal to 0. Alright, and that gives me x squared plus 2x plus 1 is equal to 0. X squared plus 2x plus 2 is equal to 0. So the reason of doing that is now I'm going to take that and I'm going to long divide that out of x to the fourth minus 5x. Ooh, let's not do minus 5x. Let's do plus 0 x cubed minus 5x squared minus 10x minus 6. Okay, that's kind of all out of whack, so let's see. Let's move it over. Let's try this again. So over here, I've got x squared plus 2x plus 2, dividing it into x to the fourth plus 0x cubed minus 5x squared minus 10x minus 6. Remember, you can do this with synthetic division if you want. I get x squared. That gives me x to the fourth plus 2x cubed plus 2x squared, and you subtract. Okay, and so I get negative 2x cubed minus 7x squared, bring down the negative 10x. So when I do that, negative 2x cubed divided by x squared is negative 2x. Alright, negative 2x times that stuff gives me negative 2x cubed minus 4x squared minus 4x, and we subtract. Okay, and so first terms cancel. I get negative 3x squared, and I get negative 6x minus 6, and that goes into it a negative 3 times, and I get negative 3x squared minus 6x minus 6 is 0. That works. So I can set x squared minus 2x minus 3 equal to 0, which gives me x minus 3, x plus 1 is equal to 0, x is equal to 3, x is equal to negative 1, and don't forget the given, negative 1 plus I, and its conjugate, x is equal to negative 1 minus I. So those are your roots for this.